recording in order to take notes. That's up to you. You can. Okay? So this is going to go over all of Chapter 1. I'm going to breeze through some of the stuff that I know we've talked about. However, if I'm breezing through it and you are confused, you need to raise your hand. Okay? Friday, since it's a short day, after we've taken the test on Thursday, test is 39 questions, by the way. We're going to set up like I had set up to do today and do some bio stuff, which is really in Chapter 2, so it's a good segue to Chapter 2 instead. Okay? So this chapter is over understanding both what hardware and software are and the fact that you need them both for a PC to work. Hardware, we already said, is physical stuff, it's touch stuff you can feel, whereas software is a set of instructions that tells the hardware how to do stuff. It's our operating system, it's our program, it's Office 2010, it's GIMP, it's Audacity, it's whatever we want to do, but those programs tell the hardware how to do specific things for us. I alluded to this. Numbers and letters are stored as a series of bits and bytes, and we measure storage capacity and capacity in bytes, which is 8 bits. I said this a number of times. Two primary input devices are our keyboard and our mouse. Primary output are our monitor and our printers, and I know those are old pictures of monitors and old pictures of printers, but you get the idea. These are our primary input and output devices, and like I said in the introduction, some of these questions come directly from the fact this is an A+ hardware certification class, and these are A+ hardware certification questions. Processing primarily takes place on the CPU. Temporary storage, which is also our primary storage, is our RAM, and our permanent storage, which is our secondary storage, things like hard drives, floppy drives, flash drives, CD-ROMs. Okay, there's nothing unfair for me to tell, and I already had you guys do this, retake it and look at that again, and you guys have already pointed out what a self-assessment is and where that is in the chapter. And I pointed out the I-CAN statements that you guys should refer to and know what they are. So you know what to expect on the test, and these are the same ones that you just answered questions on that we'll hit at the end of this if we have time. Okay, so you guys have already done that hopefully today and retaken the self-assessment. And when I say to retake the self-assessment, and it's up there when you come in, I mean today, right now. If you walk in and that's up there, I'm saying to redo it again. We've done something since the last time you did it, and hopefully answers change, and that's why I want you to redo that. Some of them will stay the same. Okay? So hardware components are used for input and output. There are all those things stored inside the case, and we talked about the primary board is the motherboard, mounted on the motherboard is the CPU, and I did not talk about the chipset specifically, which we're going to get into today. And then we have storage devices like our hard drives, CD-ROMs, flash drives, and then we have other components used for communicating on our motherboard as well. We also have what are called interface or expansion cards, and we talked about that when I talked about and showed you like the NIC and the video card, and we talked about some people still have modems for faxing and other expansion cards. So that's a term that I don't know if I use that term, but expansion or interface cards are used to expand the capabilities that the motherboard had. Okay. We talked about the electrical system, specifically the power supply unit, and the fact that it converts the kind of power from a wall into the kind of power used in electronic devices. And we talked about some of those instructions stored on the motherboard, specifically the one we talked about most last class was BIOS, or the basic input-output system that controls the boot process and stores the configuration of our computer. Stores those configuration settings on CMOS RAM. Okay, and that's definitely all these things I'm kind of pointing out are potential test questions. So BIOS is stored on, remember where that's stored? Anyone? BIOS is stored on CMOS ROM because it's read-only and it doesn't go away, right? Basic input-output system stores the configuration in CMOS RAM, and it's held there by that little coin-sized battery. We talked about in class last time. All those hardware devices are required to control our software, to communicate with our CPU, and to make those inputs that make software do what we want it to do. And we require electricity. And I already said in class the other day, this power supply powers everything. Everything is powered through the power supply. Some of them hook up directly, like the high usage power devices like CD-ROMs and hard drives, and some of them get power through the motherboard, but the power all comes from the power supply. Okay. Said this was common input, keyboard, mouse, output, monitor, and printer. Do we think that's going to be on the test somewhere? Yeah, that's going to be on the test somewhere. Okay, hopefully that's a gimme question. We looked at this picture earlier when we were talking about how to hook up PCs. You guys have hooked up a number of devices at this point, so hopefully you know those connections. Do you guys have any questions on the connections on a PC? I'm not going to spend a lot of time on this. Okay, we know that if we have a choice between an onboard or an expansion card on video, we always choose the expansion card. If you see a picture, which one is the one I would plug in my monitor to, and you have choice A and choice B, you always choose the expansion card. And in general, if I have a choice between an onboard, and these are the onboard motherboard devices, meaning on the motherboard, that term's new, versus the expansion, I always choose the expansion as my primary, okay? And we've already looked at this picture once. Input, output devices, kind of connections. We have two kind of connections. We have PS2, which are the round ones with 6 pins, a little notch, and we have USB. These are two kinds of ways to connect keyboards and mice. PS2 or older connection, what color is the keyboard? Potentially a picture that doesn't show it. So this is definitely a test question. We went over this in class. The keyboard and the mouse are different colors. What color is one of them? Can anybody remember what either one of them is? What? Green is which one? You're right, green is the mouse, and the keyboard is purple, right? You will see a question with the end saying, this is the plug-in for the, and it's going to be one of those colors, and you should be able to know that if it's purple, it's almost always the keyboard, and if it's green, it's almost always, and I say almost always because HP used orange every once in a while and stuff, which was totally non-standard. I'm going to say 95% of the time this is true. 95% of the time it's the right answer, and I won't ask you the confusing answer in the test, okay? Orange won't be an option. So you guys need to know that, because if you plug the wrong one in the wrong thing, it's not going to work right, okay? Particularly on older machines. And then we've got printers, and really what now? All printers are either USB or network printers. Having the old 25-pin parallel port means you've got a really old printer, and your computer may or may not have a connection for it. I don't think there's this kind of connections on these laptops anymore, is there? I doubt. And I need to put a new picture here just to replace this one. We've got, that's a VGA, the blue is VGA. And if you remember, I said the white one is called DVI, which is a digital video input device, versus the analog VGA. Most of our stuff is analog right now, so you'll see the blue plug there for that. Okay, inside there we've got our motherboard, which houses the CPU, hard drive, optical drive, we've got our power supply, and we've got our circuit boards inside the computer itself. I'm not going to go through the back. Again, motherboard, I said this in class, it's also called the main board. I don't know if I said that, but it's the most important circuit board. It's what houses and mounts the processor, which is where the majority of our processing takes place. Everything, all devices are connected to and communicate through the motherboard. either directly on them or linked by cable, and I said that in class as well. So if you saw a true or false question that had those words in it, all devices are linked to or mounted on the motherboard. These are true. Everything touches it. Okay, talked about CPUs where majority processing takes place. Okay, its storage is RAM. Its storage is RAM. That's why this is called primary storage, because to the CPU, it primarily uses memory. And some of that is on the system board, and some of it is on the CPU itself, but it's still all memory. Okay. I've already talked about CMOS, and we'll get back to that again. We have an electrical power supply that makes all that stuff run. There's a really jumbled picture of the inside of a PC showing all the wires and the places that we can have wires running all over the place. I'm not sure why I picked that one. We looked at this one before, saw that we have the back panel connectors, the spot where the processor goes in, got our memory slots, and we've got our expansion card slots. You may see a test question that looks just like that, where it's matching. And I have to know this is the back panel. This is where the CPU goes. This is where the memory goes. This is my expansion slots. Hopefully, if I give you a question like that with matching, considering there can only be 4 letters and 4 options there as well. Does anybody have any questions on that one? Okay. I don't want to go too fast, but I know some of this we've already gone over. We talked about CPUs where the processing takes place. I did not talk about the chipset. On the motherboard, we have 2 sets of microchips that control the flow of information around the motherboard itself. Okay, so it controls the flow of data and instructions to and from the CPU. And so when I look at, in fact, I'll just hold one up. When I look at a motherboard, there are always 2 chips on there, okay? And one of them in this case is underneath this heatsink. The other one's sitting right here. In the case of this one, same thing. Here's the one, and there's the other one. On a brand new one, we would see heat sinks over both of them. And we get into this more in motherboards, but this one controls stuff that goes the fastest. This is the North Bridge. There are 2 chipsets. You have one called the North Bridge. All it controls is the flow of information between the processor and the memory, the processor and the video card. So on the North is memory and video. Now, those are the 2 most intensive things that happen on your computer. Okay, so the CPU has a heatsink, and the North Bridge always has the next biggest heatsink because it's controlling the most amount of information going around. It's doing the most amount of processing, so it's always under the next biggest heatsink. The South Bridge or South chipset, although I don't know why they were called this, but controls everything else. In other words, any other information that's going around that motherboard is going through the South Bridge. USB, the network card, the keyboard, the mouse, everything else goes through here, but none of that comes even remotely close to the amount of information that comes back and forth from memory and from the video card to the processor, which is why this one gets hot and requires a heatsink. And on new ones, I wish I had a new one out here, some of these are almost as big as this heatsink, and then the South Bridge one's about that big because they're so much faster than these. Everything, all the bus, these are the bus wires underneath here, they all terminate right here at the CPU. So everything starts at the CPU, goes out to wherever it's going, and comes back to here. And if I'm not even pointing. Here's my CPU right there. That's actually the south bridge, north bridge. So we've got, here's the CPU contacts. We have our lines of data going to the north bridge, and then the north bridge goes out, and the south bridge is all the way down here. That's the other main one that's controlling the flow of information. And you see the lines going to all the PCI buses and stuff. Okay? Everything eventually terminates here at the processor. Let's see if this one shows up. Not really. So we got a plastic piece. There's the processor on this one, and then right here is our north bridge, and right down there is the south bridge. So everything goes between those, and then they go out to all the other spots. So that's what the chipsets are. They control the flow of data and instructions to and from the CPU. The north bridge controls the flow of information to the memory and video, and the south bridge controls the flow of information in every other part of the computer. And there's just a picture of that CPU underneath the ginormous heatsink. That's the one that is on my son's computer right now. He has one that looks just like that. And that copper heatsink is way more effective than any other kind of optical heatsink. So when you see a metal heatsink like that versus a copper one, which I don't have any, these are much more effective cooling the computer. That's another picture of a CPU under a zero insertion force, and we're going to talk about that when we get to the kinds of sockets that we have. One of these is called an LGA, and I pass those around. This is the kind that has just the little dots on the bottom of it for LGA or main grid array socket, and then the ones that have pins going on, like that picture on the board there. It's actually the pins go in. It's called zero insertion force because the pins should just drop right into the board. And then we've got our memory, which is our primary storage. It's also temporary. Okay, it goes away when the power goes away. And in this case, I've got 4 different memory slots here, 2 of which are in use, and we'll talk when we get to memory how memory goes in pairs. And in that case, we've got 2 sticks of memory in here, and I've got 2 open slots in there as well for memory. Memory holds all the storage information as the CPU is doing its calculations. It's called RAM, or random access memory. There are different types of RAM, but really anymore, there's only one type left. When I look at the different sticks, coming up here, look at the different kinds of RAM. Really, this is way gone. The SIMs are way gone. In fact, I have some of those that I give out as keychains if you want one. The original DIMM has really gone. That's gone. The only kind of memory left anymore is the DDR DIMM, and now we're looking at DDR, DDR2, and DDR3. In our school system, we only have DDR2 and DDR3. We've thrown away just about every PC that had DDR. It used to be all we had when I first got here. All we had was SD-RAMs, which is what that is right there, and we've migrated continually to faster and faster. I showed you this screen before. If you hit the Windows pause break key on your keyboard, it's not this one, that's a Windows XP one. But if I hit Windows pause break, for some reason it's not letting me do it from the smart thing. There we go, Windows pause break, it'll bring up the memory screen, and it's not letting me do it while it's running, so I'll just go there, and it will show the property. This is the Windows 7 one showing you how much memory is installed with this PC. If Smart wasn't open, it would run fine right now. I'm not sure what's going on. But that's the old Windows XP one. Again, I need to update some of my pictures. Okay, we have places where we store stuff, both temporarily and permanently. Temporary is primary, that's my RAM, right? Permanent is my hard disk drive. We also use other stuff as well, okay? CPU uses temporary storage to hold data, uses RAM, this is primary hold data while it's processing. When they're not being used, they're kept in permanent storage, and there's a module that swaps that stuff from RAM to hard drive and as the CPU is not using it. And then we've got our hard drives, which I don't know that we ever passed around hard drives. In fact, I just took all the hard drives out of the room that had stacked up over there. There, I guess we got the open one. Our hard drive has, we talked basically about it. It spins anywhere between 5,400 revolutions per minute up to those over there go to 10,000 revolutions per minute, and they're permanent storage. They are sealed. They're the only thing that's completely sealed in our computer. The only thing that's completely sealed in our computer. Okay, meaning that no air goes into this at all. One speck of dust in here can ruin a hard drive. If the secret head comes down on a speck of dust, it can ruin your computer. So hard drive is completely sealed. I know this one is open, but it's the only sealed thing inside a PC. So if I ask you what is the only sealed component inside a PC, it would be the hard drive. Okay, not saying that's on the test, but it could be on the test. Okay, now these have. Let's see if I can find one of them. Little diaphragms on them so that they can handle change, because obviously there's air inside them, but they're made in a clean room so there's no dust, and they have a little diaphragm that expands as the temperature and pressure change. I think this is the diaphragm on this one right here. It says void of warranties removed. That actually can go up and down as the change of pressure happens. There's not a whole lot of air inside them. They're completely sealed, which is why they are able to work for so long, because nothing can get in them to ruin them, theoretically. Okay? A hard drive can get really hot if it's being used a lot. That's why these ones that are 10,000 RPM, these Velociraptors, are housed in these big, huge heat sinks. This is the hard drive. The rest of this is just heat sink to dissipate heat around the outside. In fact, you can unscrew those 4 screws and take this out and put it right in a server. Inside part of it, there's like a server case that I've got. You can take and put them in or out. In fact, I might do that before, because it just slides out of the mounting once you take off those 4 screws. But these can get really, really hot. In fact, while we're talking that, I'm going to give you a number that you need to remember that you'll see on a test. 185 degrees. Above 185 degrees, electronic components fail. Above 185 degrees, electronic components fail. If you have something inside your computer that gets that hot, and I have, had hard drives get above 200 degrees before. Our server closet, when we didn't have any HVAC in there, the room itself would be 98 degrees, and you've got this server running with 1,000 of us using it. And that drive's not ever slowing down, and all of a sudden it fails on me. And it says your drive was 215 degrees. And I could look and see, at any time I can see what the temperature of the, smart enough drives that report are inside the network. So if I want to go and run, where's my room, 70 degrees now, yay. I have a program called Newt, and if I go and run Newt, and I'll let it run while we're talking, I'll come back to it and see how hot some of the PCs are in the district. Newt does a scan. It'll go through every single PC that's on right now. It'll report to me the heat of the PC and the heat of the hard drives inside there. So we'll come back and take a look at that when it's done running the scan. It'll be just a couple minutes. 185 degrees. That's a temperature at which electronic components fail. Okay? That's a bad temperature. We don't want that temperature. Hard drives have a couple of different ways of connecting. We will talk about that when we get to the hard drive chapter, and that's determined by your motherboard. A better motherboard takes a SATA connector. The old one will take a PATA connector. And this is at least 2 times, up to 5 times faster, this one is, than this one, at just transferring the data. So we have actually got rid of every single one of these in the district as well, the older PATA connectors. It's called secondary storage. but it is permanent. It includes CDs, optical drives, hard drives, flash drives. As we know, we don't really use floppy disks anymore. Okay. Information cannot be processed by the CPU off those devices. It has to be loaded to memory, which is why the more memory you have, the faster your PC is going to run, because it can load more at a time into memory and then go to this less. Because it's constantly transferring stuff back and forth between primary and secondary storage. And there's different ways they connect. I'm not going to go too much into those. They all require not only a data cable, they also require separate power for all the storage devices that are connected directly to the CPU. I really need to update those in some of these pictures. They're really old. I'm not even going to spend much time on them because none of our devices use those connectors anymore to hook up our hard drives. We talked about optical drives in class. I'm going to go back past those real quick. We talked about video cards and the fact that they have both their own processor or graphics processing unit, that have their own memory, or they can have their own memory, because if they don't, they steal it from the motherboard and the CPU, which makes your computer run slower. So you want a better video card, the faster your computer's going to run. We talked about expansion cards, video being the most common expansion card, and then network interface card or network card being the second most common one that people upgrade. Okay. The motherboard itself is where all the information moves along. It moves along the buses, the south and the north bus. We're going to talk more about the data path size or width of the bus. That's really a chapter 4 thing that I don't want to spend too much time on. I will not be asking you about data bus widths. Any questions on that? The other thing I forgot to mention is system clock. When we talked about the startup, the way the startup happens, I neglected that, okay? So we push our power button. We get a response back from the motherboard whether the power's good. And then we start clock pulses, and this is what I forgot to mention. And then we do our power on self-test, okay? There is a clock. There is a crystal on the motherboard, and they don't look like that anymore, but there's a crystal on the motherboard that generates pulses at a certain rate, and that's the rate that information moves around the motherboard, okay? It generates clock pulses, so a clock generates pulses at a certain hertz, or certain cycles per second. That is how fast everything moves around the motherboard. So if our motherboard is a 1200 megahertz motherboard, which is a good speed today, that means it's going around at 1200 million cycles per second. That's how fast that is pulsing, and that's how fast information goes around. And that system clock is what synchronizes the movement of information around the motherboard. Okay? And that's one of the things that I did not bring up. I just said this so everything terminates at the bottom of the CPU. I already showed you guys expansion cards that we can put in. There's different kinds of expansion cards that we can slide in, and we're going to talk more about the kinds of expansion cards in Chapter 4 when we talk about motherboards themselves, so I'm going to kind of go ahead with that one as well. But expansion or interface cards, I don't know anybody who uses that term. I always use expansion cards, by the way. Interface or expansion cards are just those slots that allow us to add additional things to our motherboard that didn't come with or on our motherboard. And they're easily plugged into after you plug them in, and we'll talk about what drivers are next chapter, but you have to install the right drivers to make them work. And there's all kinds of slots and all kinds of devices you can put on interface or expansion cards. Then the last thing we talked about was power supply, which turns our AC power, which is in Chapter 3, turns our AC power into DC power that our electronic components can use. So it turns, call it 50 volt AC into 5, 12, 3.3 right there. And it's what keeps our temperature at 185. I don't know if I said Fahrenheit. Okay, apply the 185 C. This is just a picture, and you guys have looked at power supplies as I've passed around. So those are our devices. We talked about those in a different lesson, and that's my review. Has anybody got any questions? I want to look at the what you guys said. You guys had questions on. So let's see. So everybody said yes, yes. Can you explain the difference between hardware and software? Somebody said they couldn't. Can you? Whoever, you don't have to say who it was. Hardware is stuff we touch. Software is stuff that runs on the hardware. And this is, I really have a hard time believing that anyone said that today. So maybe somebody did retake their thing today. Can you explain what CPU stands for? CPU stands for Central Processing Unit, and its function is where the majority of the calculations and computations take place. It's the brains of our PC. Basic function of the motherboard is to serve as the nervous system where all the information goes between the CPU and all those other devices. Primary storage is what? RAM. Okay, primary storage is RAM, is memory. Secondary storage is hard drives, CD-ROMs, flash drives. Explain what expansion cards are. They're just any card that you can add to your motherboard to expand the capabilities beyond what originally came on the motherboard. Can you explain what a power supply does? I just said that. It turns our wall power, alternating current, alternates back and forth. DC current is direct, and electronic devices require direct current. So it turns that wall power into lower voltage and direct current that we need for our PC to run. And you look at motherboard, explain the basic parts. Everybody said yes. Those 4 are really, really basic. I mean, that's as basic as we're going to get in chapter 1. I'll be with you in just a second. Is onboard components, CPU, memory, and expansion. That's really, really basic. When we get into chapter 4, you're going to have to be able to pick out a whole lot more than that. Yeah.
Hey, I'm sorry to interrupt. I was trying to get on the mobile access the other day for H drive.
Yeah. Have you tried it from here at school too? And you may be in a different group, and that may be causing a problem because we moved you in that one admin group. That's probably why. Put in a work order, will you, and I'll test you. Same mobile.nationaltrail.us. Yep, okay. Are you guys using that at all at home? No, okay, so, but it works, right? Okay. I think it's just Mr. Boston, so. Okay. Can you explain what BIOS and BIOS ROM are? BIOS is the program, and the ROM is where the program is stored. Okay, ROM is just a chip. It's just a little chip on the motherboard where those data instructions that are BIOS are stored. Okay, that's all it is. And CMOS RAM is where the configuration is stored that we change in BIOS. And it's stored and held there by that CR2032 battery. We need to buy one. It's a CR2032. They're always CR2032s. And they sell them cheaper at Walmart than just about any place you can buy it. So if you ever get gate time is wrong, it could be that going out. Just be careful if you ever take that out, because I've had students actually break the brackets on the motherboard when they're taking it out, and then trying to hold it in with duct tape. Seriously, had students that I walk in, I'm like, what the hell is there duct tape on the motherboard for? Yeah, it's not that hard to think. Anyway, so CMOS RAM is where the configuration is stored that you guys change. BIOS ROM is where the actual program is stored. It runs. Okay? Questions? If we have time, we can even do the BIOS stuff I'm going to do today, because we got actually the number of slides in there. Maybe I talk too fast. So there's a lot of stuff we already went over. I just wanted to make sure there was nothing that all of a sudden the test you go, oh, I've never seen that. They look like nothing matters. Man, this thing, I didn't have my coffee. Mama didn't make me no coffee this morning. Okay.